Good morning to all. Am I audible? Can anybody message me in the chat box? Am I audible? Good morning to all. So I'll start my class. So today we will discuss power relations in AC circuits. So let us see what is meant by an instantaneous power in an AC circuit. So I will just expand this. We already know what is power. Power is rate of doing work. Electric power means rate of doing electrical work. So today we want to see what are the different powers in AC circuit. So first of all, let us see what is meant by an instantaneous power in an AC circuit. So if it is an instantaneous power, then usually, not usually, instantaneous powers are measured at certain instant of time. For example, if you see in this waveform, if you see in this waveform, I have divided this. This is a sinusoidal waveform. I have considered only one cycle here. This is positive half cycle. This is positive half cycle. This is our negative half cycle. So I have considered only positive half cycle. I have divided that positive half cycle into different intervals. I have divided into different intervals. So let us assume that at instant t1, okay, at instant t0, I can say t0, at instant t0, what about current? At instant t0, current is 0. At instant t1, how much is the current? I1. At this particular instant, current is I1. At instant t2, current is I2, and so on. At instant at instant tn, current is In. So I have divided this half cycle into different intervals. Okay, I have divided it into different intervals, and at each instant of time, I am just mentioning the current. At that particular instant of time, t1, current is I1, at t2 current is I2, at t3 current is I3, at tn current is In. Okay, so I1, I2, I3, In are the instantaneous currents at each instant of time. Okay, they are the current at each instant of time. At certain particular instant, what is the current that we can get it from this graph. Okay, similarly, okay, if I want to determine the instantaneous power, okay, first of all I must know, we know the power relation P is equal to V into I. We already know that P is equal to V into I. Okay, P is equal to V into I, that we already know. So here, if we want to determine the instantaneous power, we must consider instantaneous voltage and instantaneous current. So instantaneous voltage is denoted by small v, instantaneous current is denoted by small I. So the product of small v and small I is our instantaneous power. Means small v is instantaneous voltage, small I is instantaneous current. We already know power is equal to voltage into current, isn't it? So power is equal to voltage into current. So if I consider voltage as the instantaneous voltage, how to determine instantaneous voltage or instantaneous currents? You can get it. You can get it from this waveform. It's a sinusoidal waveform. So here I have considered current. Instead of current, I can mention voltage. Okay. So if it is voltage, this is V1, this is V2, this is V3, and up to Vn. Okay, V1, V2, V3 up to Vn. So instantaneous power can be obtained from instantaneous values of voltage or current. So what is the definition of instantaneous power? It is the value of electric power in an AC circuit measured at certain instant of time. So if you are able to measure the power at certain instant of time, that is known as instantaneous power. So which is given by small p is equal to V into I. Small p is equal to V into I. Okay, so now the voltage equation for sine wave we already know. V small v is equal to Vm sine, I have written here. So small v is equal to Vm sine omega t. Now we can have different phasor relations between voltage and current. Now if you observe here, I am showing you a waveform in which this is the instant when voltage waveform starts. This is our voltage waveform. Okay, and this is the instant when current waveform starts. So according to this, we can say that voltage waveform is ahead of the current waveform. So there is a phase delay between these two. How much is the phase delay? Phi. Phi is the phase delay between these two. Okay. So similarly, I can take two more waveforms, voltage and current waveform. You can see here. So here at instant 0, at time 0, what about current? Current is maximum when voltage is still 0. So current is leading voltage here. Okay, current is leading voltage. So whereas if we consider another waveform, in this waveform, if you see, if you see in this waveform, both voltage and current are 0 at the same instant, both are becoming maximum at the same instant, both are becoming 0 again at same instant. So we can say the phase angle difference, the phase difference between voltage and current is 0, that is phi equal to 0. Phase difference between voltage and current is 0, that is phi equal to 0. So we can say voltage and current are at same phase. So what is our voltage equation now? V is equal to Vm sin omega t and I is equal to Im sin omega t. Okay, now let us go back to the previous waveform. So here in this waveform, voltage and current waveform, this is current waveform and this is voltage waveform. What we have seen is that at t equal to 0, voltage is 0, but current is maximum. Okay, current has already reached to its maximum value. Therefore, we can say current leads voltage, okay, by some phase angle. Okay, so there is a phase difference between voltage and current. So it is leading. So phi is the phase by which you can see, phi is the phase by which current leads voltage. Okay, current waveform leads voltage by phi. So since current is leading voltage, so what you have to do is, in the current equation, if this is our voltage equation, V equal to Vm sin omega t, this is our voltage equation, then the current equation I should be equal to Im sin omega t plus phi. Why plus phi? Why did we write plus phi? Why? Because the current is leading voltage by an angle of phi. Okay, there is a phase angle difference between voltage and current here. Current is leading voltage by phi. So similarly, if we see in this waveform, okay, if you see in this waveform, this is our voltage. So at time 0, voltage is 0. What about current? Current might have been some negative value. Current might have been some, if I extend this waveform, it might have been some negative value. So current becomes 0 at certain phase delay with respect to voltage. Okay, with certain phase delay with respect to voltage, current is becoming 0 here. So there is a phase angle delay of some phi of current with respect to voltage. Therefore, if V is equal to Vm sin omega t, then what about current? I is equal to Im sin omega t minus phi. Why minus phi? Because current lags voltage by phi. Okay, current lags voltage by phi. So let us go back to our power, instantaneous power. Once again I will start. So what is instantaneous power? It is the value of electric power in an AC circuit which is measured at certain instant of time. Okay, so I hope you have understood what is meant by instant. Okay, that is known as instantaneous power, and instantaneous power is measured in terms of instantaneous voltage and instantaneous current. So what is instantaneous power? It is equal to the product of instantaneous voltage and instantaneous current. One second. One second, wait. There is some issue with the screen. Screen is not changing. Okay then. Now let us see what is P is equal to V into I. P is equal to V into I. Instantaneous power is equal to instantaneous voltage into instantaneous current. So P is equal to V into I. Therefore, what is V here? Let us assume that current lags voltage by phi. Okay, current is lagging voltage by phi. So what is voltage? Instantaneous voltage equation: V equal to Vm sin omega t. I is equal to Im sin omega t minus phi. Okay, so I is equal to Im sin omega t minus phi. Why minus phi? Why did we write minus phi? The reason behind that is current lags voltage by phi. Current lags voltage by phi. Okay, so V is equal to Vm sin omega t, I equal to Im sin omega t minus phi. So we are assuming that current is lagging voltage by an angle of phi. If they are in phase, then this phi value will be equal to 0. If current is leading, this will be sin omega t plus phi. Okay. Now we know instantaneous power. What is it? P equal to Vi. What is V? Vm sin omega t. What is I? Im sin omega t minus phi. We have assumed that current lags voltage by an angle of phi. That's why omega t minus phi. So now multiply and divide by 2 to this equation. So if you multiply and divide by 2, Im, Vm are constant. You can keep them aside. So Vm, Im by 2. So Vm Im by 2 into sin omega t minus phi. So it is 2 sin omega t and sin omega t minus phi. So you can rewrite it as cos phi minus cos 2 omega t minus phi. So if you replace it with this term, and if you further simplify, you will get P equal to Vm Im by 2 cos phi minus Vm Im by 2 by 2 cos 2 omega t minus phi. Just I will make certain settings changes. Okay, I will continue. So this is it. P is equal to Vm Im. P equal to Vm Im by 2 cos phi minus Vm Im by 2 cos 2 omega t minus phi. So if you observe here, there is no frequency term in the first. There are two parts here. P has two parts, first part and second part. Okay. So in the part 1, there are no frequency values. Okay, in part 1 there is no frequency value, whereas in part 2, if you carefully observe, there is omega. Omega is what? 2 pi f. Omega means so what is omega? Here you can see in the second part there is Vm Im by 2 cos 2 omega t minus phi is there, whereas here it's a constant term. Okay, it's a constant term. If you know Vm, Im and phi, you can determine this first term, whereas in second term, as frequency varies, what is omega? Omega is equal to 2 pi f. Omega equal to 2 pi f. So if frequency changes, this whole second term will change. Okay, if frequency changes, this whole second term will change. So you can see omega is multiplied with 2, so we can call this second term as double frequency term. Okay, so the magnitude of the average value of this term, if I determine the magnitude of the average value of this term, it will be always 0, because the average of a sinusoidal quantity over one complete cycle is always 0. Okay, so therefore we will neglect this term. Why? Because its magnitude for one complete cycle will be always 0. Therefore you can neglect it. And what is our instantaneous power now? P is equal to Vm Im by 2 cos phi. So we are neglecting the second term. Why? Because its magnitude changes with double the frequency, and for a one complete cycle it will become 0. Okay, so therefore what is instantaneous power now? Instantaneous power is P is equal to 1 by 2 Vm Im cos phi. Okay, so this is we can call this as the average power of an AC circuit. This instantaneous power, you can call it as average power of an AC circuit. Okay, so instead of writing 2, I can write 2 as root 2 into root 2. I can write 2 as root 2 into root 2. So P is equal to Vm by root 2 Im by root 2 cos phi. Vm by root 2, we already know Vm by root 2 is the RMS value. Im by root 2 is also RMS value. Okay, if you remember RMS value, you can recall it. So Vm by root 2 is RMS value, Im by root 2 is RMS value. So instead of writing Vm by root 2, you can write a capital V. Im by root 2 can be replaced by capital I. Okay,